In this first of a series of introductory videos in macroeconomics, I discuss the goods market, and a useful textbook is the one by Blochard Olivier, published in 2021, Macroeconomics, the 8th edition, published by Pearson. The point of departure for the treatment of the goods market in macroeconomics is the national accounts identity, where here we know already the gross domestic product, or GDP, of a country is defined as the value of all the goods and services that are produced in this particular country within a given year. According to the national accounts identity, we then have three possible ways of computing the GDP. The first one is to sum up all the goods and services, the value of them that are produced in an economy. But this would lead to double accounting. For example, we would count the tires of a car and then the car itself. So we need to subtract all the intermediate inputs. So that amounts then to summing up all the value added and is typically denoted by Q. The second way of computing GDP would be to sum up all the incomes in an economy, labor income and capital income. And that would actually lead to everything that can be spent in this economy. Now, if the economy is closed, and considering that inventories are just negligible, we would have that summing up all incomes would lead to the same as summing up all the value of production of goods and services. So Y, which is the sum of all incomes, would be equal to Q, which is the sum of all the value added. And the third method would be to sum up the demand. That means demand for goods by households, by firms, and by the government, and this is typically denoted by Z. Now, as I've said before, all three of these methods need to lead to the same outcome. Of course, in reality, there are some discrepancies that are due to statistical issues, and of course, it's not always possible to measure everything perfectly. So there will be discrepancies, but by and large, the three methods should lead to the same amount, and therefore the equilibrium condition is that Q is equal to Y, and this is equal to Z in a closed economy where nothing can be imported or exported. Now we will use this actually to describe the goods market equilibrium in an economy. In doing so, we follow the third way of calculating GDP, so summing up demand, where we then have that aggregate demand is equal to consumption by households, so C is consumption expenditure of households, I is investment expenditures by firms, and G are consumption expenditures of the government, and that's equal to total expenditures in a closed economy. In an open economy, we would also have the component of exports minus imports. Now, for the components, it's reasonable to assume a certain dependence on underlying variables. So consumption itself is usually seen to positively depend on income. That's clear. If households earn more, they can consume more. And negatively on taxes. That's also clear because the difference between what you earn as a gross income and the taxes that you pay, that's disposable income. So what actually matters is disposable income. So taxes that you pay would decrease consumption of households. In terms of investment by firms, they also increase with income. The reason is that if incomes in an economy increase, then firms would be induced to invest more because they anticipate higher demand. But investment in turn depends negatively on the interest rate because the interest rate is the rate at which companies can borrow money to invest. Of course, if the interest rate increases, investments become more expensive and therefore investments decrease if the interest rate increases. And governmental consumption is usually seen to be exogenous, so the government just decides on a certain amount of spending that is, in this case, typically denoted by G upper bar if it's exogenously given. To keep the analysis simple, but nevertheless capture the dependencies that we just talked about, it's typically assumed that linear functions describe consumption and investment. So a typical consumption function used in the literature is that consumption is given by C0, which is autonomous consumption, the amount people would consume even if they had no disposable income, because you need food, you need a certain amount of shelter and so on. So even if households have no income in a period, they might necessarily be spending something on consumption. That's autonomous consumption. And then we have consumption that depends on disposable income, where C1 is the marginal propensity to consume out of disposable income, and disposable income itself is the difference between gross income, Y, and the taxes that the household has to pay. So C1 describes if the household has an increase in disposable income, how much of this increase the household spends. So that's the fraction C1, and the rest, 1 minus C1, would be saved. And for investment, it's typically also the case that the linear function is assumed, where D0 is autonomous investment, so that's investment that firms would perform anyway, even if there is no demand and the interest rate is 0. So that might be, for example, some replacement investment that is necessary that the firm runs. Then D1 is the demand response of investment. So if demand increases, by how much firms would increase their investment. And D2 is the interest rate response of investment, by how much firms would decrease investment if the interest rate rises. Now it's standard to assume that the parameters are all positive, so autonomous consumption, autonomous investment, the marginal propensity to consume, and the responses of investment to income and the interest rate, and that the marginal propensity to consume plus the responsiveness of investment to income, that they are together smaller than 1. Otherwise, the equilibrium, as we will see later, is not stable. Then overall, we have the total demand is given by demand of households, demand of firms, and demand of the government. And we can plug in the linear functions that we've seen on the previous slides. So we plug in the linear consumption function from the previous slide, the linear investment function from the previous slide, and exogenously given government expenditures. And then we see here that income shows up in this term and in this term. So we can summarize the two. We would have C1 plus D1 times income. And so we have this as a collected term here. And C1 minus times the taxes with a negative sign is here. The equilibrium condition, as we know, is that total demand set is equal to total income. And we can now solve for the equilibrium, which we will do next by means of a graphical analysis. In this graphical analysis, we first depict demand set on the vertical axis and production income Y on the horizontal axis. Now along the 45-degree line, we have all the points for which aggregate demand is equal to aggregate output or aggregate income Y. So the equilibrium of the goods market will definitely be located along the 45-degree line. To determine the equilibrium, we draw the second line that we had before, and that's the line of aggregate demand, which is equal to consumption expenditures of households, investment expenditures of firms, and governmental consumption expenditures. And we know that this line actually starts at a positive value for an income that is equal to 0 because of autonomous consumption and autonomous investment, and potentially also positive government expenditures. So even if income is equal to 0, we know from the previous slide that expenditures at the aggregate level could be positive. What we also know is that as income and production increase, the slope of this aggregate demand with respect to income increases is less than 1 because the two parameters C1 plus D1 were less than or 1. So we will definitely have that at some point the aggregate demand curve will intersect the 45-degree line here because this line has a positive intercept and a slope that is less than 1. The point of intersection then is the goods market equilibrium. So that's the point where demand is equal to supply, and that is the equilibrium level of income and production that is equal to total demand actually. Now this is the simplest depiction of the goods market in an aggregate economy and its equilibrium. where the economy is closed. In an open economy, we would also have imports and exports, and how imports and exports are affected by exchange rate dynamics, because of course if the currency appreciates or depreciates, this will have different effects on exports and imports. And with these results in mind, we can next study the so-called multiplier effect, by which income changes if the government changes either its expenditures or its taxes.